And even in your worst times, you are committed to do the hard work, and it's not based on success. That to me is the real game here, because that is eventually God's test.
Good morning, my dear students. I'm Leon Joshi. Hereafter, I'm going to teach the lessons only in English because it is CBSE syllabus. So I have to take the classes only in English or in Hindi. I don't know Hindi. So I'm going to take the classes only in English. Now we are going to read the question of example 5. Show that the relation R in the set Z of integers given by R equal to A comma B 2 divides A minus B is an equivalence relation. Now let us see the solution. R is reflexive as 2 divides A minus A for all A belongs to Z. Further, if A comma B belongs to R, then 2 divides A minus B. It is simple that they are writing A minus A because for all A belongs to Z means A to Z, the all integers belongs to Z. So that's why they are writing A minus A for all A belongs to Z. Further, if A comma B belongs to R, then 2 divides A minus B. They are writing as well as what gives in the question. So therefore 2 divides B minus A. Hence B comma A belongs to R, which shows that R is symmetric. Similarly, if A comma B belongs to R and B comma C belongs to R, then A minus B and B minus C are divisible by 2. Now, A minus C equal to A minus B plus B minus C is even. Why? So, A minus C is divisible by 2. This shows that R is transitive, thus R is an equivalence relation in Z. Now we saw the proof. We are going to elaborately see the solution of this example. In example 5, note that all even integers are related to 0 as 0, plus or minus 2, 0, plus or minus 4, etc. That means they are saying that even numbers means 2, 4, 6, etc. lie in R, that means lie in relation, and no odd integer is related to 0. That means 0 is not odd number as 0, plus or minus 1, 0, plus or minus 3, etc. do not lie in relation R. Similarly, all odd integers are related to 1 and no even integer is related to 1. Therefore, the set E, that means E of all even integers. Why they are denoting E means in even E is the first letter. That's why they are denoting E. O means odd integers or subsets of Z satisfying following conditions. Number 1. All elements of E are related to each other and all elements of O are related to each other. That means all elements of E means even numbers. Even numbers are related to each other. All elements of O, that means odd numbers. Odd numbers related to each other. Number 2. No element of E is related to any element of O and vice versa. It means no element of E, even numbers, is related to any element of O, odd numbers. So 2, 4, 6, 8, it will be in single sequence, and 1, 3, 5, 7, it will be in another single sequence. It will never be related to each other. Number 3. E and O are disjoint and Z equal to E union O. That means E and O will be different. Then the set Z equal to U union O. It will be like this. The subset E is called the equivalence class containing 0 and is denoted by square bracket 0. Similarly, O is the equivalence class containing 1 and is denoted by inside the square bracket 1. So, the subset E will be denoted as inside the square bracket 0 and the odd number O will be denoted inside the square bracket 1. Note that 0 not equal to 1, 0 equal to 2R. R means a rational number and 1 equal to 2r plus 1, r belongs to the integer, that means z. In fact, what we have seen above is true for an arbitrary equivalence relation R in a set X. Given an arbitrary equivalence relation R in an arbitrary set X, R divides X into mutually disjoint subsets AI called partitions or subdivisions of X, satisfying. Nothing, don't get panic. They are trying to confusing you. They are introducing new set X. They are introducing new subsets called AI and AJ. If these sets and subsets are created, what will be the conditions? Now we are going to see these things. Number one, all elements of AI are related to each other for all I. Number two, no element of AI is related to any element of AJ, I not equal to J. Number third, union of AJ equal to X and AI intersection of AJ equal to pi. That means empty, I not equal to J. The subsets AI are called equivalence classes. The interesting part of the situation is that we can go reverse also. For example, consider a subdivision of the set Z given by three mutually disjoint subsets A1, A2 and A3 whose union is Z with A1 equal to X belongs to Z. X is a multiple of 3. The set will be minus 6 to 6. That is a multiple of 3 set. A2 equal to X belongs to Z. X minus 1 is a multiple of 3. Subtract minus 1 from the above set. That will be the minus 5, minus 2, 1, 4, 7. A3 equal to X belongs to Z. X minus 2 is a multiple of 3. Uh, Now subtract minus 2 from the first set. Then the set will be minus 4, minus 1, 2, 5, 8, etc. Define a relation R in Z given by R equal to A comma B 3 divides A minus B. Following the arguments similar to those used in example 5, we can show that R is an equivalence relation. Also, AI coincides with the set of all integers in Z which are related to 0. A2 coincides with the set of all integers which are related to 1. And A3 coincides with the set of all integers in Z which are related to 2. Thus, the subsets will be A1 equal to 0, A2 equal to 1, A3 equal to 2. In fact, A1 equal to 3R, A2 equal to 3R plus 1 and A3 equal to 3R plus 2 for all R belongs to Z. It is very easy sum, but you should read and listen very carefully. Next, we are going to see example 6. Let me read the question. Let R be the relation defined in the set A equal to 1, 2, 3, 4, 5, 6, 7 by R equal to A comma B. Both A and B are either odd or even. Show that R is an equivalence relation. Further, show that all the elements of the subset 1, 3, 5, 7 are related to each other and all the elements of the subset 2, 4, 6 are related to each other, but no element of the subset 1, 3, 5, 7 is related to any element of the subset 2, 4, 6. First, read the question very carefully and slowly. You may find a great solution. Now we are going to see the solution. Given any element A in A, both A and A must be either odd or even, so that A comma A belongs to R, a relation. Further, A comma B belongs to R, both A and B must be either odd or even, implies B comma A belongs to R. Similarly, A comma B belongs to R and B comma C belongs to R, implies all elements A, B, C must be either even or odd simultaneously, implies A comma C belongs to R. Hence, R is an equivalence relation. Further, all the elements of set 1, 3, 5, 7 are related to each other as all the elements of this subset are odd. Similarly, all the elements of the subset 2, 4, 6 are related to each other as all of them are even. Also, no element of the subset 1, 3, 5, 7 can be related to any element of 2, 4, 6 as elements of 1, 3, 5, 7 are odd while elements of 2, 4, 6 are even. That's it. The example is over. Thank you. I'll see you on my next video.